And we're glad we have you here today for a deeper dive into NERC PRC-028. So just to go through a quick agenda, we'll cover some quick disclaimers. We'll give you an overview of NERC Standard PRC-028. We'll cover each one of the requirements. We'll give you some compliance actions that you can take to be compliant. We can do any summaries at the end, and we'll take some questions. So with that, we'll cover some disclaimers. GridSme cannot endorse any product. I've got some examples in the slides that you'll see here in the future. As much as I want those examples to be compliant, they may or may not be compliant. PRC-028 is new and it's technical, so always work with your EPC and your engineering provider for a compliant solution, as there is no easy button. So I wanted to pull apart where GridSme can and can't help you. So GridSme can help you with some initial equipment lists to help you be compliant. You can take those to your engineering or EPC provider, and they'll help you design a compliant solution. Once you get those designs back, if you want GridSme to take a second look to help make sure it's compliant, we can do that. We can also help you build any models and perform some simulations. So unfortunately, because each site is a little unique, we can't design the engineering solutions for you. You'll need your engineering EPC to check those designs and equipment gaps. So PRC-028 is your disturbance monitoring equipment standard for inverter-based resource facilities. It provides a base equipment requirements for verifying that you are compliant to NERC Standard PRC-029 and your voltage and frequency ride-through standard. It will also help you identify power change events for NERC Standard PRC-30. It's going to apply to your inverters, your main power transformers, your collector breakers, and your dynamic reactive devices. It's going to cover equipment like sequence of event recorders, fault recorders, and dynamic disturbance recorders. To summarize requirement 1, this is your sequence of event requirement standard. You can think of it as having two parts: your substation part, where you're monitoring your breaker open and closed statuses, and your field part, where you're gathering different data for your inverters, such as your alarm and fault codes, your voltage and frequency operating modes. This requirement does have a legacy plant consideration. If you had a commercial operation date prior to April 1 of 2025, you can ask for an exemption to the inverter data requirements. However, you have to demonstrate that your inverter is not capable to qualify for this exemption, as NERC won't take your word for it. To summarize requirement 2, this is your fault recording data and location requirements. You'll need fault recording data at your main power transformer, your collector breakers, and your dynamic reactive devices. You'll need to record data like your phase to neutral voltages, your phase currents, your neutral and your residual currents, your over and under frequencies, and your real and reactive power. Requirement 3 is still your fault recorders, but these are the capabilities. NERC is going to want to make sure that you have a 2-second record length, that you have a 2-cycle pre-trigger, that you can sample at 64 samples per cycle, that you're time synchronized at plus or minus 1 millisecond of accuracy, and that you can put data out in CSV or ComTrade formats, and that data can be retrievable for up to 20 days. Requirement 3 also contains trigger type information, so NERC is going to want you to trigger on certain neutral or residual overcurrents, your over and under voltages, and your over and under frequencies. Turning to requirements 4 and 5, these are your dynamic disturbance recorder continuous recording capabilities. They're going to want to make sure that you capture one or more voltages, currents, or frequencies. If you're just capturing one, they're going to want to make sure that they're all in the same phase as in phase A. They're going to want you to capture your real and reactive power, and they're going to want to make sure that you have data for up to 20 days. For capabilities, they're going to want to make sure that you have 960 samples per second, and that you can output at 60 times per second, that you're time synchronized to plus or minus 1 millisecond of accuracy, and then you can put data out in the right formats. Requirements 6 and 7 are your time synchronization and data formats for all of your disturbance monitoring equipment. Again, they'll want everything to be time synchronized to the right accuracies for your location, and they'll want you to put data out in the right formats. Requirement 8 is a procedural requirement, not an equipment requirement, but we'll cover it briefly. As of January 1, you needed to have procedures for a disturbance monitoring equipment loss. And once that equipment is installed and active, you will need to actively monitor for equipment loss and take corrective actions within 90 days. So that's just sort of an overview of PRC-28. We'd like to give you some systematic steps or an approach that you can use to be successful with NERC Standard PRC-28. Some steps you could take is to first engage that EPC or engineering firm. Then you can say, I'll need to list what PRC-28 functions are needed where, such as at my main power transformer, my collectors, my dynamic reactive shunts, or my inverters. And to show that, I've got an example plant set up here to the right. At my far right, I've got a high voltage bus. I've got some high voltage breakers, breakers 1 and 9 in black, followed by 2 main power transformers, transformers 1 and 2, 2 collector buses, buses 1 and 2, 4 collector breakers, and 23 individual inverters. What I've done is I've shown a colored box for each PRC-28 function at each location that it's required. So at each of my main power transformers, I've got 3 boxes. I've got a green dynamic disturbance recorder box, a fault recorder box, and a blue sequence of event recorder box. Going down to my individual collector breakers, I've got a fault recorder box and a sequence of event recorder function listed. And then at my inverters, I only have my sequence of event recording function listed. So once you understand what functions are required where, then you can gather and make a list of your field equipment and try to decide which field equipment will cover each function, which I've got listed up in the right. And then I can look at my design requirements and look for gaps. My design requirements as for a fault recording, I've got listed off to the bottom right. So once you have that, you can gather any evidence. You can think of actual event data when you're operational. If you're not operational, you can look into commissioning tests, specifications, or configuration files. To take those steps and to sort of put them in an inventory form, an example where you might be compliant, I've listed an example inventory for my plan example. So on my left-hand side, I've got my locations, my main power transformer 1, and my main power transformer number 2 in this case. I've got which PRC-28 function is required at those main power transformers, my dynamic disturbance recorder, my fault recorder, my sequence of event recording functions. Then I've listed what field equipment I have out there that should cover those requirements or capabilities. In this case, for the main power transformer 1, I've chosen some Schweitzer equipment like an RTAC, a satellite clock, and some relays to cover my fault recording and sequence of event recording functions. And then in the following columns, I've got which data that I'm gathering to be compliant. For main power transformer 2, rather than using Schweitzer equipment, I chose maybe I can choose a capable digital fault recorder that can cover all of the functions in one box. Turning to my collector feeder breakers, again, I'm listing which feeder breaker I'm at, breakers 5, 6, 7, and 8, what PRC-28 function that I'm covering, my fault recording function or my sequence of event recording function, which device I'm using to cover those functions, and the data that I'm gathering to be compliant. If I have a shunt dynamic reactive device, such as a capacitor or a reactor that's under AVR control, it's going to look a lot like those collector breakers. Last, I can list my individual inverters that I'm trying to capture my sequence of event recording data using those inverters and what data that I'm capturing as an example for my inventory. So now that we've taken a look at an example plant and an inventory, let's sort of break down each one of the requirements and some compliance actions you can take to be compliant. So you can work with that engineering EPC contractor. You can gather a list of field equipment that you've got, list what PRC functions you need, where. You can look at your design requirements and check that you have the needed capabilities, and you can look for any gaps. Once you have that, you can look for any evidence of compliance, such as commissioning tests, specifications, or configuration files. Another way that you can also be compliant is to look at what's called a Reliability Standard Audit Worksheet. This is sort of a cheat sheet for a compliance audit. NERC will give you some example questions that they're likely to ask during an audit. And in this case, they're asking you, do I have all of the right breaker, open and close positions at my main power transformer, my collector buses, etc.? And at my inverters, am I gathering all of the right data to be compliant? On the far right here, I've got an example data sheet from a piece of equipment that I'm using for my sequence of event requirement. And at the very bottom right, you can see that it says that it has the sequence of event recording capability. I'd keep this data sheet as an example that my equipment should be compliant to requirement 1. Another thing that can come up with requirement 1 is your inverters and aggregating all of that inverter data together. Steps that you can take is to ask your original equipment manufacturer for any technical statements or bulletins or specification sheets. Once you have those, you can then think about what equipment do I have that can gather all of these data points together, that can time synchronize them, and that can put data out in the right formats. Some examples might be RTACs, some digital fault recorders, and or data concentrators. Turning to requirement 2 and taking those same compliance actions or steps, I can work with my engineering EPC contractor for requirement 2. I can gather a list of the field equipment that I have that should cover requirement 2 and our fault recorders. I can list what functions that I need where for PRC-028. I can check my needed design requirements or capabilities. Those are shown off to the right. And then I can look for any gaps. Once I have those functions done, I can look for any evidence, such as actual events or commissioning tests, specifications, or configuration files. Next, I can turn to the NERC RSAW, and NERC can help me walk down through a series of questions of what data am I gathering where. And if I can answer all of these questions, there's a good chance that I'm going to be compliant. Turning to requirement 3, following those same steps, work with that engineering EPC contractor, gather that list of field equipment, list my PRC-028 functions, and check my capabilities, which in this case, I'm looking to see if I can sample at 64 samples per cycle. Can I provide a 2-second fault record length? Am I time synchronized appropriately? And can I put data out in the right format? Turning to that NERC RSAW, NERC is going to ask you those same capability questions, and then they're going to ask you about trigger settings for each one of the data points. Thinking about evidence, NERC is going to ask you about, well, do you have the right evidence to show me? And on the bottom right here, I've got an example of a configuration file that's showing that I'm sampling at 64 samples per second for 120 cycles, which is 2 seconds. And then I'm gathering all of the right current, voltage, and frequency data. Turning to requirements 4 and 5 for our dynamic disturbance recorders and applying that same framework. Again, work with your engineering EPC contractor. Gather a list of your dynamic disturbance recorders, which in this case is verifying, does each dynamic disturbance recorder cover a main power transformer high side? Is it gathering all of the right voltages, currents, etc.? Is it recording continuously? And then I can check against my design specifications and look for any gaps. So on the right is my design specifications, and on the bottom right are 2 example data sheets of digital fault recorders that I might use for the DDR function. I can then turn to the NERC RSAW, and the RSAW will lead me through a series of questions to help make sure that I'm compliant. Same for requirement 5, I can turn to the RSAW and they'll have some capability questions asking me, am I sampling at 960 times per second? And can I output data at 60 times per second? And do you have evidence to show me? Then turning to requirement 6, this is for all of my disturbance monitoring equipment. And my time synchronization requirements, NERC is going to ask me about, do I have all of the right time synchronizations at all of the right accuracies, whether it be plus or minus 1 millisecond at the substation or plus or minus 100 milliseconds out at the inverters, and do I have all of the right evidence to prove it? Turning to requirement 7, following that same process, we can check do we have data that can be stored for up to 20 days? Can we check the equipment outputs and the formats for my sequence of event, my fault recording, and my dynamic disturbance recording equipment? And please note that I did see some examples out there where you might need some additional software to convert the data to the right formats, such as ComTrade or CSV format. And I've got an example of that here down on the right that shows I've got some equipment and it says it can convert the data to the right format. And then we've got some audit questions that you can walk through for using the NERC RSAW. And then last is requirement 8. This is more of a procedural requirement, but NERC is going to ask you some questions about, do you have the right documented processes, and have you discovered any disturbance monitoring equipment failures? Please note that auditors may sample or request all events as evidence. So that's requirement 8. And now just to briefly talk about a standard that's a new future standard, EOP 4-5. This is a standard that the industry just passed and is waiting for NERC and FERC approval. So it's not law, but when it is approved by FERC, EOP 4-5 will add what's called an inverter-based resource generation loss reporting requirement that will be made to the balancing authority. So while talking with your EPC or engineering firm, you can ask them about this future potential requirement, and are there synergies with the PRC-028 equipment that I'm already specifying that can help me with this future EOP 4-5 standard. So, all right, well, that's a quick summary of what we've got for the PRC-028 deep dive, and I will check for questions.
Thanks, Terry. We have a couple questions here for you. First off, can you please provide the link to where the RSAWs are located?
Sure, that's a great question. I'll try to navigate out to the website and show you how you can navigate. So if you're interested in the RSAWs, you can go to the programs area on the NERC. First of all, you can go to the NERC website, which I have up in my browser. You can go to the programs drop down. You can look for the compliance. My computer, there it is. So once I'm in the compliance drop-down area, I can go to reliability standard audit worksheets on my left navigation there. And then I can navigate down to the PRC standards. There's a long list of PRC standards. I can scroll down to NERC Standard PRC-028. And I can open up the RSAW. So now that I have the RSAW up, you can look for those NERC summary questions. To list the requirements, and then here are your NERC requirements or questions or audit items for each one of the requirements in the blue boxes. So that's an example of how to navigate to the NERC RSAWs.
Great, thank you. Do you know if GridSme will have resources available to support these assessments?
GridSme can support some of the assessments. Again, we can provide you with those initial design or equipment lists that then you can take to your engineering or EPC provider. They can give you an actual compliant design, and then once you have that, if you want us to take a second check, we can look at it for compliance.
Okay, great. Another question for you here. The 30-second reporting obligation in the updated EOP language appears to be a little bit harsh. Do you have any insight into when this requirement is expected to become official? And then also, as you understand it, does the 30-second threshold apply only to a complete site outage?
Great questions. So first, I probably need to clarify that the 30 seconds is not that you have to report within 30 seconds. Actually, the balancing authority will report within 24 hours according to EOP 4. But the 30 seconds is to make sure that there's a time for any transients to die down. So you would only report a generation loss after 30 seconds if it's sort of permanent and your unit didn't recover. Thinking about when the standard will become effective, FERC needs to approve this standard, and then you'll have 12 months after FERC approval. So I'm guessing this could be next year at this time, approximately.
Okay.
And then, let's see, I think the third part of that question, let's see, could you read the third part of that question again?
It was just about if the 30-second threshold
Yes, okay.
applies to complete site outages.
All right. And no, I don't think it'll be a complete site outage. It does talk about a generation loss, so I think it could include a partial loss.
Okay. The next question I have is about if you've seen any common compliance gaps across the facilities. Um, have you seen any yet?
Sure. We have noticed a few places. So if you have relays that are attempting to get a 2-second fault record length, that can be a problem for some older relays. So make sure that you're checking on their capabilities or with the manufacturers that you can indeed capture that 2-second record length. Another problem area might be gathering and time synchronizing all of the individual inverter data. So there's a lot of data out there to capture and gather, and you've got to time synchronize it and make sure that you can put data out in the right format. So that might be another common bottleneck that we've seen so far.
Okay. Last question for you here regarding the new version of EOP4. When you reference the 30-second threshold, does any of that loss automatically need to be reported to our BA?
Let's see. Partial loss would be reported up to your balancing authority, and then that would only be after that 30-second period had elapsed to make sure that it was indeed a true generation loss.
That is all the questions. So thanks, Terry, for your presentation.
Well, thank you so much.